I am Marcia McNutt. I'm the president of the American Geophysical Union, and I welcome you all to our session on Earth and Space Science in Europe. First of all, let me explain to you the format for our session tonight. We will have two speakers. Banda, who is the Secretary General of the European Science Foundation, and David Southwood, who is soon to become the Director of Science for ESA, the European Space Agency. After their presentations, we will have sort of a panel question and answer type format, and adjourn the session at 6:30. Each speaker will highlight the challenges and opportunities that face Earth and space scientists in Europe from their perspectives, both as from their own science work and also as administrators. So without further ado, I'd like to introduce the first speaker, Banda. Dr. Banda is, of course, a citizen of Spain. He received his doctorate in physical sciences from Barcelona University. He did some research in Zurich, but since that time was director of the Institute of Earth Sciences in Barcelona, and held other positions in Barcelona and Madrid. Most recently, since 1998, he has become Secretary General of the European Science Foundation in Strasbourg. Dr. Banda has distinguished service at the AGU. First of all,
devoted to science policy, my talk will concentrate on that. And what I would like to do in these 20 minutes that I have been allocated is to give you a few hints of what's going on in Europe. Just a few hints. If I get there, I will have achieved my objective. Let me say from the outset that the European Science Foundation is not a funding agency, so not to be confused with the National Science Foundation. ESF is not a funding agency, it's rather a coordinating agency, and this might distort my views or the way you interpret my views from the beginning. So since we are going to talk about Europe, we should agree on a definition of Europe, and I'm not going to do that because this is an impossible task. Whether you tackle this problem from a history viewpoint, well, it would be easier from a geological point of view. We would say from the Urals to the Mid-Atlantic Ridge, and that's it. But I don't think politicians would like that one. So when we talk about Europe, I show this map, which is what I call an ESF map, and this is only because these are the countries from which we have member organizations. It's 23, 24 countries in Europe. But the logical thing to do in terms, for the sake of simplicity, is to talk about Europe in terms of the European Union, which is 15 countries now, but it will be 25 or more within the next decade or so. And in any case, whatever I say, it can be extrapolated to a larger Europe. And therefore, I'm not going to waste any more time in describing which Europe am I talking about. Now, I will start with a few indicators. Just for you to know what's going on in Europe, I think it's useful to compare your system, the American system, the US system, and the EU 15, as I call it here, which is the present-day European Union, in terms of size. And for that, there's a number of economic and science and technology indicators that you may believe more or less, but in general, you should give me credit that it gives you a rough idea of what the size of the systems are. And I'm not going to read the numbers, but in terms of population, in terms of gross domestic product, in terms of publications per million inhabitants, in terms of overall scientific outputs, in terms of publications as well, and in particular for engineering and earth and space sciences, and for patents, I mean, we are talking about systems of the same order of magnitude at least. And therefore, one is tempted to say that the two systems are comparable. And I would go along with that statement, except that they are comparable in size, but there's considerable differences when you look at the details, or not at the details, but rather at the social and economic organization of those systems, and I'll get back to that in a minute. Another way to look at the intensity of investment in the research and development is to express the expenditure in terms of percentage of the gross domestic product. And here you see the evolution of three powers in the world. One is the US in red, where you see the evolution since 1990 up to 1999, where you stay at 2.7% of the gross domestic product. You see Japan ahead of all of us, presently at 3.1, and you see the European Union down there. I hope you can see it from the bottom, at 1.8. Of course, this is a relative measure, and you can interpret it in different ways, but this is reality. Now, another way to look at it is not to look at percentage, but to look at the actual expenditure and compare with the others. And in the upper part, that's the difference between EU 15 and Japan, with a positive balance in favor of the European Union, with a constant gap since 1990. But then if you look at the lower part of the slide, that's the gap between the European Union and the US, which is constant in the first half of the 90s, a total of, say, 45 or 40,000 million dollars. But from 94 onwards, there is the increase in the gap is tremendous, is alarming, and as a European, I'm a little bit ashamed of it, and I don't even want to think about extrapolating this gap, because then in 2010, I don't know where we will be. So this is what the indicators give us. And I insist that I have not come here all the way to give you a talk about the indicators. I wouldn't dare to do it. But I think that with that, you can realize that we're talking about systems that are comparable, I insist, in terms of size. Now, let's get now to Europe, and I'm sure that by reading the first bullet in the slide, you will say, well, Europe is a complex system because of this. I mean, multicultural, language, tradition, religion. We have the same thing in the US. I mean, that's perfectly comprehensible. You will say that. But there is one difference, and the difference is that in Europe, we have these things concentrated in what we call countries, or nations, or nation states, if you want to call it that way. So we have a concentration of power, in the case of the EU 15, in 15 powers, in 15 focus, and a little bit of power at the European level with the European institutions. And this is reality. And of course, this distribution of power has a lot of influence in how science is managed and how science is prioritized and how priorities are being set, etc., etc. And therefore, this is a completely different, not the detail, it's a completely different characteristic from the American system. Not to talk about identity. I mean, social scientists in Europe are looking for a European identity for a long time, and I'm not sure that they have found one. And this is reality. Now, with this picture I'm giving you of Europe, what is the funding system in Europe? How do we deal with funding in Europe? Well, the first thing, as a consequence of what I have just said, is that funding is nationally led. So it's national interest of every one of the different countries that counts. This is reality again. There is some influence by the European Commission, by the European Union through the European Commission, but the funding comes, 95% public funding comes from the countries, and this is what dominates the scene. The European Union, second line, has an instrument called the Framework Program, which is the way they finance science, and it is important. 5% is something like 3 billion euros a year. It's not negligible, but it's not comparable to what the nations spend altogether. Not for me. The framework program, in addition, has one problem, that because of the treaty of the European Union, it is written very clearly in articles so and so that research expenditure for science and technology has to be for the competitiveness of European industry. Of course, you can read this in different ways, but this is what it says, and this is what is used by politicians to say yes or no to certain science expenditure. So with all that, what I want to say, and it summarizes quite well what I have said, Europe is not a federal system at all. So if you want to compare it with your own system, Europe is not, it doesn't have a federal system yet. And of course, you don't want to compare Europe actually with NAFTA, but maybe it would be more accurate or more fair to compare it with NAFTA rather than comparing it with the United States only. Now, and within countries, if it is nationally led, how does it work, the funding within the European countries? Well, within European countries, everything is different. There's a lot of diversity, and every country has different ways to deal with things, and this is natural. But it would be comparable. You would not be surprised of the system, of the national systems, as they work when you compare it with yours. I mean, we have a lot of power being concentrated in ministries, in your case it's departments, then we have our own research councils, and you have National Science Foundation and an NIH if you want, and then we have another group of national research organizations that could be equivalent to some of your national labs that draw the budgets from different sources. So that's the situation of funding in Europe, and I cannot resist to mention the role of understanding-driven research in a world in which, with increasing pressure for applications. Accountability seems to be the word. As a scientist, I fully understand, as a public being paid by money from the taxpayer, I completely understand that I have to be accountable, but I get mad when I'm being made accountable with practices that have nothing to do with my job. And this is what's happening, unfortunately, in many places in Europe. I may sound fundamentalist, but we can discuss this later. Now, research priorities, in fact, seem to be dictated more and more by governments. We have seen in the last several years some increases in the science budgets in Europe, very encouraging. But increases, they always come with labels. They come labeled earmarked, which means that they tell us where to put our brains. And I don't think this is the best way for science anyway. So what I see behind this, the government's giving priorities is economic interest, and I think that all of you can agree with that, although we may discuss this later. Now, let's get to priorities. On priorities, I have been in geophysics for many years, and of course, before coming here, I took my time to ask some friends what's going on in Europe, apart from my own information from the European Science Foundation, and from the grassroots. I'm not saying that this is a priority that has been agreed by governments, but from the grassroots, there's a few examples that I'm going to give you. One, for instance, would be what we call Euromargins, where I show the volcanic margin, the North Atlantic, but I could have shown the non-volcanic further south. There seems to be enough critical mass in Europe, when you take it as a whole, to establish programs and to break through this part of science. The same could apply to the relationship between climate and tectonics. I think this figure is from years. And talking about climate, of course, I could mention the need to get into the Holocene climate record, or to see for the last million years or so the synchronicity of what is happening in the North Hemisphere, in the South Hemisphere. So all these priorities come from the bottom, and I'm sure they coincide quite well with your own priorities here. Now let's move to a different subject. We have always said that in Europe we know how to collaborate. And does it really work, the collaboration in Europe? Well, the answer is yes. I mean, we are used to collaborate. We have had the necessity to collaborate because of critical mass, because of resources, and there's a number of mechanisms that we have in place that work, but we have to improve it. Things are changing in such a pace that we have to improve it if we don't want to lag behind. Now, as I say, there's a number of success stories, but because before I get into that, I should say that the FP, the framework program, has been very successful in creating certain EuroproPace among European scientists, because they have spent since 1984 a lot of money in networking scientists, and therefore there is a habit of scientists working together in networks from different nations. Now, among the success stories, of course, I could show you, I could talk about the European Space Agency, which I don't dare to, because David, I'm sure, will tell us all about in a few minutes' time. But I can show you the European Southern Observatory, which has its central observation point in Chile, or I could show you the CERN, where you see, you see the Geneva Airport on the left, and you see the ring, the projection of the ring of the accelerator with a cross line, which is the Swiss and French border, so the accelerator goes through both countries. And the CERN itself is run by an association of 20 different countries, and they have been successful, the particle physicists, in running CERN for the last nearly 50 years. And as you know, they are building now the Large Hadron Collider. So this could be thought as success stories in Europe, but it's not enough. I think we still have to improve. So in all that, what is my institution going to do with European science? Well, in a region with so many countries looking after their own national interest, I think we have to recognize that the fact that some visionaries back in 1974 decided to found the European Science Foundation was the right thing to do, and maybe the time has arrived that they will be it will be shown that they were right, because there's so much movement at this point that I'm sure that the ESF will have a major role in European science in the future to come. I'm not going to go through the characteristics. I'm sure you have read them all by now. Now, some success stories as well coming from ESF. Well, you can imagine that scientific projects that need to gather I don't know, 25 different countries, as you can see at the bottom part, including the United States, at the bottom part of the slide. It's a difficult thing, but we have been successful. EuroproPace is a program led by Professor David G. in Uppsala, and it comprises 9 different projects with different targets, using the whole lot of geophysical instruments, geophysical, tools to reveal a number of problems in European geology. We could talk about the quaternary environment of the Eurasian North, led by Professor Tide, where they have obtained excellent results in terms of the past climate. Or we can talk about the response of the Earth system to impact processes, that look at the structures and processes due to impacts. And this particular program has been quite successful in integrating young scientists, and we are very proud of it. So before I finish, I really want to say something that some of you that have friends in Europe may have heard about a European research area. There is now the Commission in Brussels is 20 commissioners, and one of them has in its portfolio research. And Commissioner Biscayne, he has now launched the idea to build a European research area with the aim that you can read in the slide. There's nothing new behind, but maybe he has felt that now it's a time to do it. And it has received quite a lot of credit and quite a lot of political support. But still, there's a lot of reticences from national interest, but we are all excited in Europe about changing the things, changing some things to improve, especially to avoid duplication and to avoid or to make profit actually of the critical mass that we can have by having Europe as a whole. Now, I will take to finalize a slightly higher vision, which is, well, fine, in Europe we need more collaboration, probably we need more collaboration between Europe and the US, but in general what we need, scientists, is more collaboration among ourselves. And therefore, what I would like to submit to you is that we need new and better mechanisms for collaboration. This is what I think. As scientists, we have, of course, our own loyalties with our environment, with our family, even with our funding agency, but in the end, professionally, we are science-driven. And as such, I don't think nationality has a lot to say. And this is why I believe that research to produce science deserves mechanisms in which nationalities should not be an obstacle. If we are fighting back in Europe to pull down this barrier, why should not be done at global level? That's something that I thought I've been thinking in the recent past when talking a lot about pulling down these barriers in Europe. I mean, why should we stop in Europe and not doing it worldwide? I'm afraid that the mechanisms for international and intercontinental collaboration are not in place. And from the grassroots of science, we find the heaviest possible bureaucracy when we want to tackle a problem in which we need different nationalities to work together. So I propose to work towards a globalization also in the scientific work, and not only at the level of scientists, but at the level of funding, at the level of funders. This may only be a vision, but as such, this is my prediction and my dream for the future. Now, since I started talking about Europe, I don't want to leave without showing this figure that indicates the number of attendees to the European Geophysical Society assemblies back in Europe since the late 80s. As you can see, there is a steep increase in participation, close to 5,000 now, and I guess I'm proud myself to have contributed to this a little bit. Back in Europe, there's also the European Union of Geosciences, which is Strasbourg-based, and that overlaps with the European Geophysical Society in part of the solid Earth. But what makes me happiest of it all is that I have learned that there will be a joint meeting of AGU and EGS in Nice in April 2003. And I think the best signal the scientists can send is get together and discuss science. Thank you very much.
Okay, our second speaker is Dr. David Southwood. Dr. Southwood was a PhD student at Imperial College and stayed on there for a number of years researching magnetic fields in space. He also built the Cassini-Saturn orbiter for monitoring magnetic fields in space. During his time at Imperial College, he was head of the Space and Atmospheric Physics Group and also served as head of the Physics Department. Finally, in 1997, Dr. Southwood passed over to the dark side, becoming an administrator as the head of Earth Observing Strategy at ESA, the European Space Agency, where he initiated the ESA Living Planet program. As of May 1st, this coming year, he will become Director of Science at ESA. Dr. Southwood also has distinguished service to the American Geophysical Union. He formerly chaired the Fellows Committee for AGU and also has chaired the Fleming Medal Committee. So, Dr. Southwood.
Well, good evening. It's a great pleasure to be back here. My current credit is Imperial College London, but I'm in between two appointments in ESA. The European Space Agency is, in my view, a successful example of Europe working together in the rather peculiar way that we do work together in Europe. And first, to say, ESA does work in both the geophysical and the planetary sciences. They're looked after by two different directorates. Earth Observation, which looks after Earth sciences, where I used to work, is in the Directorate of Applications. The current director is Claudio Mastracci. And solar terrestrial physics, and planetary science are looked after by the Directorate of Science. The current director is Roger Bonnet, and I will take over from him on the 1st of May next year. ESA, as with any European organization, does not have a unitary aim. Indeed, the aims vary as viewed from country to country. There certainly isn't any doubt that ESA was founded with the aim of enhancing European capability in space science and applications. It's also to build a European industrial technical capacity. This actually goes against many of the aims of the European Union, which is not to particularly look after industry per se, but to make industry competitive. However, in aerospace, there isn't a level playing field, and we can perhaps talk about that. And finally, it's to bring together and get more out of the whole than you get out of the individual national programs. And it is important to remember everything begins at the national level in Europe of today. There's a map of the reduced Europe that belongs to the European Space Agency. It doesn't conclude everybody, because you will see at the end of the flags there, Canada, which is a closely cooperating state. It closely cooperates without being geographically close. In particular, it plays a large role in our Earth observation program. The budgets, if you look from this year, the year 2000, the total budget for Earth observation and science, the areas that would interest the AGU, is around 848 million euros. That used to be of order a similar number of dollars, but we've revised the exchange rate slightly. ESA is run by a series of political bodies. In particular, the ones that matter to us, apart from the Council, which has national representatives on it, are the Science Program Committee, which covers space science. The members of that committee have the final say on what goes on in our program, and the committee is made up of national representatives. Earth observation and earth science in particular is covered by the Program Board for Earth Observation, made up similarly. All those bodies are made up by delegations appointed by research councils or governmental bodies in each member state. This is not a satisfactory way to pursue science. in my view, and I hope in your view too. As a result, we have fought hard to ensure that scientists, the scientific community as a whole, actually have a major control over the overall program of the agency. In space science, that is well established now, with Solar System Working Group, an Astronomy Working Group, and a Fundamental Physics Advisory Group feeding their ideas into the Space Science Advisory Committee, which advise the Director of Science and the Director General of ESA, but also make recommendations to the Political Committee. The membership of all advisory bodies is determined by individual scientific standing, not by passport or by national delegation. This really is an important element in making science drive things and actually keeping the quality of the program high. In Earth science, we have recently introduced a similar structure with an Earth Science Advisory Committee which advises the executive and at the same time makes recommendations to the political body, the Program Board. The Program Board had some difficulty in understanding this, but they are getting the hang of it. And I think it's making a major change in the quality of the science done within the program and with the way science is chosen. You'll note that we have a cross-membership, both in the Science Advisory Committee and the Earth Science Advisory Committee, with the ESF Space Science Committee, which is supposed to be an external arbiter of whether we're doing our job well. And they actually then link back to our member states by the research councils, etc., that make up ESF. So I repeat that statement. I'm going backwards. Okay, let me now come to the science. The ESA program, Space Science Program, is a small fraction of the American program, and that is something obviously one wants to change to make a more competitive situation. Nonetheless, in the last 20 years, I think it's fair to say, we've established ourselves as an independent entity and in a leadership role in certain areas. I point out the currently operating solar system missions like SOHO, Ulysses, and actually Cassini-Huygens. One hopes Huygens is going to operate. We're optimistic about that, for those of you who know the technical situation. In fact, Cassini-Huygens is very much a child of the ESF in that the cooperation to go to the outer planets from a European base was through an interaction between the ESF and the National Academy of Sciences in the United States. I'd like now to talk about something where I feel personally very involved, and I should add is also an operating mission now, the cluster mission. This was first part of the biggest firework display the planet has seen in some time, when Ariane 501 blew up on June the 4th, 1996. This year, the 4 Cluster 2 spacecraft were launched successfully on 2 Soyuz rockets from Kazakhstan. And the point of the matter of principle is that ESA has to somehow establish a level of trust with the scientific community. And we have, I think this exemplifies what's happened several times, of a commitment to deliver the program we say we are going to deliver. This is an extreme instance, and, but I could name others. The recovery of SOHO was done with a strong commitment to the sense that we are committed to the community to do that. I think this is a very important principle and one that could be applied in other countries too. You can take a look at our program and it's interesting to do so, to try and look at a thematic approach. I'm not entirely happy you get this right. In particular, if I take solar exploration and Sun-Earth connection, the general field I've worked in most of my career, clearly with Ulysses, SOHO, Cluster, a potential mission in 05, which is a gleam in my eye at the moment, and then a gap until Bepi Colombo, the Mercury mission in 2009, and then Solar Orbiter in 2011. In a sense, that is a program. It's a sense of continuity into the future, but it's a thin program for such a large number of scientists and for such a large scientific community. One step is to integrate in national programs, Ørsted, Picard, and so on are mentioned there. Of course, other steps are to cooperate with the United States or with Japan. And of course, Bepi Colombo will be a cooperation with Japan. Cluster and SOHO and Ulysses are all cooperations with the United States. On the planetary science front, where Europe used to be weak, I think we can say we are much stronger now. In the future, we're building towards a lunar mission, Smart 1, Rosetta, a cometary mission with a lander, Bepi Colombo, which includes a lander for Mercury and 2 orbiters, Mars Express with a lander called Beagle 2, and potentially a mission in 05, which is yet to be fought out politically. So there I think I can give you, sorry, I'm key to be, that's it. You can, again, produce a thematic picture, which actually is probably better balanced, starting from Cassini-Huygens and actually moving through, looking at different aspects of solar system exploration with a large element of European leadership. Now, I'd like to turn back to my past, to Earth science, and I'd like to say where we are now. The big advance, and something I'm immensely proud of, was the political acceptance that we could have a science-driven program when ministers agreed to this in June 1999. We have a new funding arrangement that gets a lot of the politics out of the detail of the funding, and a program based first and foremost on the scientific priorities of the European scientific community. Europe is in fact no slouch in Earth observation, but it has had to build big spacecraft because of the need for everybody to get their political share of each spacecraft. That was okay when big spacecraft were fashionable. And, you know, frankly, there's no doubt ERS-1 and ERS-2 were really very effective spacecraft, primarily originally looking at ocean measurements, but actually yielding returns by use of civil radar in areas that were totally unexpected, and indeed forcing certain nations to release lots of material that was defense-related, that suddenly no longer seemed to be as secret as it used to be. Next year, we see the launch of EnviSat, which is the daddy of them all. It's a giant spacecraft, and we could not go on building such spacecraft efficiently, is my view. It's going to be a beautiful mission when it flies, but you can't build missions that size effectively trying to keep everybody happy and keep up an appropriate rate of throughput of science. So I'll pass over. So we have now a new science-driven mission based on smaller spacecraft and much more focused missions. The aim is to get to 1 launch a year, and at the moment I have no reason to feel that isn't achievable. By having a long-term program, mimicking space science, in Earth science, we can seriously talk to the Japanese and the USA about cooperative missions. In particular, the Japanese took us up very readily on this, and NASA is coming along too, I think, in a productive way. There you just see a series of names. I should tell you something about them. Thus kicked off so far is the Global Ocean Circulation Explorer, pronounced. One of the problems of being European is there is no way of pronouncing a word uniquely, sometimes called GOSE, or GOCE, or GOTHE, or probably in 101 other ways. I don't know how to say it in Estonian, but it's a wonderful mission focusing on gravity gradient measurements, but with an enormous level of impact across Earth science, from ocean circulation, unification of a height system, earthquakes, ice sheet melting, sea level change, etc., etc. At the bottom we have something which again I regard as a wonderful mission, the Atmospheric Dynamics mission, or ALICE, which is a LiDAR mission, sort of the holy grail in some respects of measuring winds in clear atmosphere, where we genuinely believe we've got the answer, and we're going to prove it in the next few years. As you probably know, this has been a holy grail for about 20, 25 years, I suppose. We really think we've got the answer, and if we get it right, of course, it'll make a massive difference in the operational. It'll feed into operational meteorology, I trust. Then we have even smaller missions. CREOSAT is the number one. These are sort of PI-led missions. CREOSAT is a spin-off from radar altimetry, for measuring accurately the polar ice cover using radar techniques. It's complementary to the laser-based US mission. And then finally, another one that's been a gleam in people's eyes for a long time, a soil moisture and ocean salinity mission called SMOS, that will, if we get it right, have a large effect in terms of feed through to applications, and in particular for things like desertification and so on. To encourage people, we have the principle of holding a mission in reserve, and at the moment that's an atmospheric profiling mission called ACE. If either of these starts slipping on schedule, there is one waiting ready to slip in behind. Last month, the next phase of explorers were selected, and here is a list of them. ACE is a remarkably simple acronym that seems to be overused, perhaps. There are 5 missions selected per Phase A studies, with the next selection stage in the autumn of 2001. Thank you very much.